Every photon in these first EHT images began its journey in a churning maelstrom embedded in the most extreme environment in the known universe, the vicinity of a black hole. In M87, the crucible in which these photons were born was powered by the black hole in two distinct but related ways. First, via an accretion flow, a violent disk of orbiting gas driven inextricably toward the event horizon. By the time the material is making its final plunge, it is crashing into itself at nearly light speed, transforming the gas into a 100 billion degree plasma. Second, through astrophysical jets, narrow beams of outflowing material speeding away from the black hole at nearly the speed of light. These jets are powered by black hole spin. Rotating black holes drag everything, gas, magnetic fields, and photons, about themselves, driving these paradoxical structures whose cosmic importance will be discussed by my colleague Sarah Markov. In M87, one of these jets is pointed very nearly toward us. The EHT images are influenced both by these bright emitting regions, the rotating accretion disk and outflowing jets, and by gravity itself. In general relativity, radio waves fall just as apples do. Typically, this effect is exceedingly small, but black holes are gravity run amok. The radio waves we see in these first images orbited the black hole before beginning their 55 million year journey toward us. This results in the dark shadow or silhouette cast by the black hole's event horizon upon the emission from the accretion flow in the jet. Importantly, the size and shape of the shadow is determined by gravity alone. General relativity makes a clear prediction for both of these features. To within 10%, the shadow should be circular, with the diameter determined solely by mass, multiplied only by fundamental constants. However, as with all voyages of discovery, when we began this expedition of the mind, we did not know what we would find. Were Einstein wrong, or the object at the heart of M87 not a black hole, its silhouette could have been very different, misshapen or missized like those seen here, or even simply missing. Changing gravity changes how light bends, and thereby changes the shape of the shadow. In April 2017, this was the dog that did not bark. The shadow exists, is nearly circular, and the inferred mass matches estimates due to the dynamics of stars 100,000 times farther away. Today, general relativity has passed another crucial test, this one spanning from horizons to the stars. This shadow is surrounded by a bright ring of enhanced emission. Oh, we'll skip this. Enhanced emission due to those photons that just escaped the black hole's clutches. The properties of this ring-like feature result from the astrophysical dramas that unfold on gravity's stage. To understand these dramas, over the past 3 years, the EHT collaboration has undertaken an unprecedented simulation effort at research institutions across the globe. This has generated the largest collection of simulations ever assembled of the accretion flow and jet launching region in M87. The southern brightness excess arises directly from near light speed rotational motions near the black hole. Regions that move toward us at nearly the speed of light are bright. Those that are moving more slowly or away are dim. From these, we have inferred the sense of rotation of the black hole. In M87, the black hole spins clockwise. Moreover, the excellent quantitative agreement between the EHT images and generic theoretical expectations of a bright crescent-like feature with a dark interior provides significant confidence in our interpretation. The object at the heart of M87, the object that powers M87's jets, is a black hole like those described by general relativity. Importantly, in combination with infrared and optical flux measurements, we can now rule out a dim but otherwise visible surface. That is, this does indeed appear to have the defining feature of a black hole, the event horizon, that point of no return. Today, several complementary windows have opened upon black holes. Science fiction has become science fact. Together, two of these windows, the EHT, and LIGO, which reported the first detection of gravitational waves a short 3 years ago, have verified another key prediction of Einstein's theory of gravity. Despite varying across a factor of billion in mass, known black holes are all consistent with a single description. Black holes big and small are analogous in important ways. What we learn from one necessarily applies to the other.